What's up, guys? Welcome back to the channel. Quick question before we get started. Out of everything we've covered so far, either in the foundation series or in the algebra series, what has been your favorite topic so far? Or what is a topic that you're excited to see us cover? Let me know in the comments section. So, if you haven't already, do make sure to hit that subscribe button so you don't miss anything. Just an FYI, we post new lessons every Sundays and Tuesdays at 10 a.m. Okay, let's get into it. Say you're given some equation or some linear equation, x plus 5 equals 3, and I ask you to solve for x, right? We all know that in order to be able to solve for x, I want to have only x on this side of the equation, right? So what I would essentially do is move the positive 5. And the way we do that is doing the inverse of plus 5, which is minus 5, or the opposite of plus 5, which is minus 5. And now we have x only on this side of the equation, which is negative 2. But then when I introduce two variables as opposed to just one variable, right? Because in this question, I had just the one variable, which is x. But now I have two variables. I have x and y. How do I solve for x and y, right? So that's what we're going to talk about when we talk about systems of equation. Ideally, when we have two variables and we need to solve for x and y, we usually will have two equations. And now what we're solving for is a little bit more interesting, because I'm not only solving for what makes this equation true, but I'm also solving for what makes this equation true. So I'm solving for what makes both of these equations true. If you want to see what that looks like graphically, what that looks like is, say I have some equation that looks like this, right? And I have some other equation that looks like this. The point that makes both of these equations true is going to be right here where they intersect. So when I have some equation 2x plus 5y equals 7, or x minus 3y equals 4, and I ask you to find or solve the system of a linear equation, right? Essentially what you're being asked to find is the point where they intersect, if they intersect. Not all linear lines will intersect, but if they intersect, you're being asked to find the place where they intersect. And since it's a point, right, and we talked about this nonlinear equation graph, it's gonna have an x value as well as a y value, right? So this is gonna be the x value and the y value, and it's gonna be an ordered pair x comma y. So essentially I want to find the x value where it intersects. I want to find the y value where it intersects. Okay, before I move on to actually showing you how to do it, I said that sometimes they might not actually intersect, right? What would a line look like that doesn't intersect? I might have a line that looks like this, right? And I might have another linear line that looks like this. What's the relationship between these two lines? They are parallel to each other, right? And since they're parallel to each other, even if it goes on forever and ever till the end of time, they will literally never intersect because they're parallel to each other. So in this situation, if I gave you two lines that are parallel and you're asked to solve the system of linear equation, what would your system of linear equation be? Since there's no point where they intersect, you would have no solution. So that could be a situation. You could have a situation where there's no solution. We could also have a situation where we have infinite solutions. So let me show you what infinite solution looks like. Okay, so for infinite solutions, we might have a graph that looks like this, maybe. And then we might have another graph that intersects it and also looks like this. So it continues and then it goes on, right? Do we see that there's so many points where this graph intersects, right? It intersects all throughout, right? So there's so many points where this graph would potentially intersect. So then if I give you a line that looks like this, you would say that it has an infinite number of solutions, right? So we can have three cases when we're asked to solve for a system of linear equation. The first case is it's straightforward. You find your solution and it has some x value and some y value. The second case is that it has no solution because it can never intersect. And then the third case is that they intersect in so many places, and so you have an infinite number of solutions. Okay, so now that we've given that brief intro, let's talk about the different ways that we can solve for systems of equations. So we can, I'm only going to talk about two ways, but there's so many other ways. So we could do elimination. Oh, my bad. So we could do elimination and we could do substitution. So I'm going to start with substitution and then do elimination for the same problem. So my first problem is negative x plus 2y equals negative 7. And then let's make this negative. Minus 3y equals negative 14. And I want to solve for the system of linear equations. Again, what that means is you're trying to find the point where they intersect, if they intersect. And so you're trying to find x and y. So since we're doing substitution first, let's talk about what that looks like. The name essentially gives it away. Substitution, as the name implies, is literally substitute. So there's only really two things that you need to know for substitution. One thing is you want to pick a starting point. So since there's two equations, you just want to pick one of the equations as your starting point. So pick a starting point and then solve for one of the variables. Either you want to solve for x or you want to solve for y, but solve for one variable. Once you have that variable, you're going to substitute it, and that's where the name comes from, substitution. Substitute it into second equation, and that's it. That's where that name comes from, substitution. So substitution means substitute. You pick a starting point and you substitute it into the second one. Whenever I ask students to pick a starting point, it's very easy for you to make mistakes because there's quite a few steps. So something I always tell students to do is to pick a starting equation that is a bit more simplified. So if you look at these two equations, this one is a little bit more simplified because it has lesser numbers. This one has 1, this one has 2, this one has 2, this one has 3, 7, and 14. This one is a lot more simplified, right? So I will pick the more simplified one as my starting point. So I picked my starting point. I'm going to label my steps as I go through it. Steps, pick a starting point. I picked first one. Let me label it. So this is equation 1 and this is equation 2. So my starting point is equation 1, starting. Now I'm going to go ahead and solve for one variable. So which variable do we think would be the easiest to solve for in this situation? I would say that x is probably a little bit easier to solve for. So I'm going to solve for one variable, and the variable I want to solve for is x. So let's go ahead and do that. Again, when you're picking your starting point, pick the one that's easier, and when you're picking the variable you want to solve, again, pick the one that's easier. That would just help you to reduce the chances of making a mistake. Okay, I want to solve for x, which means I only want x to be here, so everything else needs to be on the other side of the equation. So the first thing I'm going to move is this 2y. So I have to do the opposite of 2y, which is negative 2y, and I have to do that to both sides of my equation. So now negative x is negative 7 minus 2y. Again, I only want x on this side of the equation. Unfortunately, there's a negative in front of x, so it's not quite by itself yet. But there is a negative 1 here, right? And it's being multiplied by x. So I have to do the opposite of that, which means multiplication opposite is division by negative 1. I have to do that to everything. I'm going to do that to negative 7, and I'm also going to do that to negative 2y, right? Okay. So let me fix this border so things don't all blend together. Okay, so now that we have that bit, I can continue this. So -1 divided by -1 will just cancel out. So x is going to be -7 divided by -7, which is +7. And -2y divided by -1 is +2y. So my x is equal to this, 7 plus 2y. So now I've solved for my one variable, right? I solved for one variable. I've done that bit. I've done this and I've done this. Now the second is to substitute it into the second equation. So since I picked this as my starting equation, this becomes my second equation. So I'm going to substitute this into my second equation. Notice that if I pick this as my starting point, this will become my second equation, so I'll substitute it into the second equation. Just make sure when you're substituting it, they are substituting it into not the equation you started with, but the other one. That's really important. So let me go ahead and substitute this back into this equation. So this equation is -2x minus 3y equals -14. Instead of putting x now, I'm going to put this because this is what my new x is, right? So let me flip to the other side because I'm running out of space here. X is equal to 7 plus 2y, right? And we're in the second part of the steps, or the third part of the steps, which says to substitute it into the other equation, right? So x, where is x here? X is right here. So I'm going to rewrite everything else except x. So let me go ahead and do that. I'm going to write everything else but x. So it's going to be -2, -3y equals -14. Now the question is, what should I put instead of x, right? Because we're not writing x anymore. So what should x be? We found that x is 7 plus 2y. So instead of writing x, I'm just going to write 7 plus 2y. 7 plus 2y replaces x. Okay, so let's go ahead and solve for this. If any bit of this is confusing, I have a video on algebraic expressions that goes through how you solve for variables or equations when there's variables. So we're just going to go ahead and do the distributive property. -2 times 7 is -14, and -2 times 2y is -4y. So it's -14 minus -4y minus 3y, which is equal to -14, right? Okay, so the only variable I have here is y, and these two are like terms, so I can go ahead and combine them. So then it becomes -14 minus 7y equals -14. Okay, now these two are not like terms, so I cannot combine it, but this -14 is a like term with this -14, so I need to combine them. There's an equal to between them that prevents us from combining it, so we need to put them on the same side of the equation so I can combine them. So I'm going to add 14 to both sides of the equation. So -7y is -14 plus 14, which is 0. So I'm going to go ahead and divide both sides by -7. So my y is 0 divided by 7, which is 0, right? So that bit is done. So now we have y. But remember, we talked about this earlier. For you to find the solution, it has to have x and y. So how do I find x? So the way we solve for x is to take this y equals 0 value that we got. So if we go back here, right, we said solve for one variable. So now we've gone back here because we're just going to repeat that again, right? So now we've solved for one variable again, which is y equals 0. And now we're going to substitute it into the other equation, right? We're going to repeat this two again. Okay, so now I'm going to go put this in my other variable, other equation. So I have like two equations. I have this equation and I have this equation, right? But I also have this new equation that I got, right? So now I'm going to put it into this new equation that I just solved for, essentially. So this is going to go in here, right? So now it's going to be x equals 7 plus 2y. Okay, do you see y in this question? Right here. So I'm going to go ahead and underline it. So I'm going to rewrite everything else but y, because y is going to be something else, right? Now the question is, what is y going to be? We said that y is equal to 0, so this is going to be 0, right? Sweet. So 2 times 0 is 0, so x is just equal to 7. Now we have both solutions. We have x and we have y, and this would be the solution. So if I plotted these two lines, the point where they would intersect would be at 7, 0. Okay, so let's try the same problem, but now let's do elimination. So elimination is, so the problem is negative 2x plus 2y equals negative 7, and then negative 2x minus 3y equals negative 14. The thing about math is we're not very creative, so when we name things, it usually tells you exactly what the thing does, right? Substitution is named substitution because you do a lot of substituting. In elimination, or sometimes you will see people refer to it as addition. It's the same thing. And the reason it's named that is because we're going to eliminate a variable by adding our equations. So eliminate a variable by adding equations, right? So I'm going to take these two equations and add them together, and when I add it together, I want one variable to be eliminated. So let's think about what that even means. If I have 2x and I have 3x, or let's start with something a bit easier. If I have 2x and I have x, and I want to eliminate this when I add it and actually just get 0, what should I make this be so that when I add it, I can have 0, essentially? I want to make the numbers equal to 0 when I add it. So what does this have to be so that when I add the numbers together, I get 0? 2 plus what will give me 0? And if you're thinking it, you're right. Negative 2. 2 minus 2 will give me 0, which means I have to multiply it by negative 2. That's essentially it. The same thing if we did a different number. If we did 2x and 3x, I want to add it and I want to get 0 when I add it. So I would have to multiply this by 3, right? And then that would give me 6, and I'll have to multiply this by 2, and that would give me 6, right? So now it would be 6x and 6x. But 6 plus 6 is not 0, right? I want to add it and get 0. So one of them I have to make negative. It doesn't really matter which one. You can just choose whichever one you prefer. So if I make it this one negative, now 6 minus 6 is 0. So this idea, we're going to bring it in here. We're going to pick one variable that we think we want to eliminate, and we're going to eliminate it. Again, the same thing as substitution. Make sure you're picking the easiest one, just so it reduces your chances of error. Since this one has a coefficient of 1, I think x would be the easiest to eliminate. So I'm going to try to eliminate x. So if this is negative 2, I want this to be positive 2, right? Because the signs need to be flipped. I want it to be the same number, but different signs, right? Because if it's the same number, but a different sign, then it's going to give me 0. So if this is negative 2, this also has to be 2, but it has to be positive 2. So I'm going to make this negative, right? Because negative 2 times negative x is going to give me positive 2x, which is what I want. But you can't only do x, you have to do the whole equation. So now my new equation is going to be negative 2x minus, because we're doing it to the whole thing, 4y equals 14, right? Negative 2 plus 2y is negative 4y, and negative 2 times negative 7 is positive 14. So let me rewrite this one since I didn't do anything to it. This is going to be negative 2x minus 3y, which is equal to negative 14. Now let's go ahead and add it. Oh, by the way, it's a good thing I caught that. Negative 2x times negative 2x is positive 2x, not negative. Okay, let's add it up together. 2x minus 2x is 0, which is what we wanted. And now negative 4y minus 3y is negative 7y. And negative 14 minus 14, or 14 minus 14 is 0. we're going to divide both sides by -7, so my y is equal to 0. Now I have y. To get x, I'm just going to plug it back into any one of my equations. It does matter. Well, really, it doesn't really matter because you're going to get the same answer. But again, I'm just going to say pick the one that's easiest, reduces the chances of making a mistake. So I'm going to pick the top one. And now it's going to be +2, but I'm not going to write y anymore. I'm going to put 0. So this is just 0. So this is -x equals -7. If I divide both sides by -1, then my x is going to be equal to 7. So x is equal to 7, and my final answer is 7, 0, which is the exact same thing that I got when I did substitution. So I'm going to do another problem, but I'm curious before I do my second problem, which one do y'all prefer? Do you prefer substitution or do you prefer elimination? And why do you prefer them? Yeah, just go ahead and drop it in the comments. Now let me go ahead and do a different problem, and we're going to use substitution and elimination. So let's do 4x plus 2y equals 10 and x minus y equals 7. Okay, I'm gonna do elimination first just because it's quicker. So I can either eliminate x or eliminate y. I'm gonna choose to eliminate y. So I want the numbers to be the same, but I want the sign to be different. So I'm going to multiply this by 2. It's going to be -2, so the numbers are the same and the sign is different, which is exactly what I want. So now it's going to be 2y equals 10, and then 2x minus 2y equals 14. Now let's go ahead and add it. 4x plus 2x is 6x. 2y minus 2y is 0. And then 10 plus 14 is 24. Now I'm going to divide both sides by 6, so my x is equal to 4. Now that I have x, I can plug it into an equation. I'm going to pick the easiest one, so I'm going to plug it into this one. So now it's going to be -y equals 7, but I'm not going to write x anymore. I'm going to write 4. Now I'm going to subtract both sides by 4, and so it's -y equals 3. And then I'm going to divide both sides by -1. So now my y is equal to -3, and my final answer is 4, -3. Now I'm going to do the exact same problem, and I'm going to do substitution. So it's 4x plus 2y equals 10, and x minus y equals 7. I need to pick my starting variable, pick the one that's easiest. I pick this one, and then I'm going to pick the variable I want to solve for. I'm going to pick the one that's easiest, and it's going to be this one. So let's go ahead and do it. So it's x minus y equals 7. I'm going to add y to both sides of the equation. So x is 7 plus y. Now I'm going to plug it into the other one, not the one I started with, but the other one, which in this case is this one, right? So now let's plug it in there. So now it's going to be 4, I'm not going to write x, plus 2y equals 10, because instead of x, what am I putting in there? 7 plus y. Okay, let's finish it. 4 times 7 is 28, and 4 times y is 4y plus 2y equals 10. So this is 28 plus 6y equals 10. We're going to subtract 28 from both sides of my equation. So 6y is -18. And I'm going to divide both sides by 6. So y is -3. Now we're going to plug it into the other equation, right? We talked about this. Now there's another other equation, because now we have 3 equations. So we're going to plug it into the third one. So now it's going to be x equals 7 plus, we're not going to write y, we're going to write the other one, which is -3. Now 7 plus -3 is just plus times minus, which is minus, so it's just 7 minus 3. So our x is equal to 4, and so we have 4, -3. Okay, I'll do one last example, and then but I'm only gonna do my favorite way of doing it, which is elimination, because it's a bit quicker. So I'm gonna go ahead and do one more example, and I'm gonna do elimination. If you prefer substitution, I'm not judging you or anything, but I am asking you why. I'm kidding. So let me go ahead and do the last example, but I'm only gonna do this with elimination. So it's negative 3x minus 2y equals negative 12. Okay, so again, I want to pick a variable to get rid of, and so in order to pick a variable to get rid of, it has to be the same number but different signs. So I'm going to pick y to get rid of it. It's already positive, so I don't have to change the signs, I just have to change the number. So I'm going to multiply this by 2. So now this becomes 4x plus 2y equals 10. I didn't do anything to this, so I'm just going to keep it like that. Now what's 4x minus 3x? That should just be x. This is canceling out, and this should be negative 2, I believe. And now I'm going to plug this into any of my equations, picking the easiest one, which is that one. So now it's going to be 2, I'm not writing x, plus y equals 5. Instead of x, what should I put? Negative 2. 2 times negative 2 is negative 4, plus y equals 5. I'm going to add 4 to both sides of my equation, so y is equal to 9, and so my final thing is negative 2, 9. Okay, let's do cases where we actually don't have a solution, because earlier I had said that you might have infinitely many solutions, or you might have a case where you have no solution. So let's do one of those cases so you can see what it would look like when you don't have any solution, or you have an infinite number of solution. Before I solve for this, can you all guess what kind of solution this variable is going to be? Do you think what kind of solution this system of equation is going to have? Do you think it's going to be infinitely many, or do you think it's going to be no solution? Go ahead and put it in the comment section before I solve for it. Okay, now that you've guessed, let's actually solve for it, and then let's see if your guess was true or not. Okay, so I will do substitution so that the people that like substitution are happy. I'm gonna pick the easiest variable to words. I'm gonna pick my easiest equation to start with, which is this one, and then I'm gonna choose my easiest variable to solve for, which is this one. It's gonna be 2x minus y equals negative 3. So I'm solving for y, so I need to move x. So negative y is negative 3 minus 2x. So now I'm going to divide everything by negative 1. So y is 3 plus 2x. So now we're going to put it into the other equation. So it's going to be 4x. I'm not writing y, which is equal to negative 6x, because instead of y, I need to write 3 plus 2x. Now it's going to be 4x minus 6 minus 4x, which is equal to negative 6. 4x minus 4x is 0, so it's negative 6 equals negative 6. I have a question for you. Is negative 6 equals to negative 6? If you said yes, you're right. So yes, negative 6 is equal to negative 6, so that's true. And since this is true, I have an infinite number of solutions because it's true. If it was false, there would be no solution. Let me give you an example where it's false. So we have 2x minus y equals negative 3, and 2x minus y equals 1. Again, I'll use substitution. Okay, so pick the easiest one to start with. No, I guess this one is easier. So pick this one to start with, and I'll solve for this one as my variable to solve for. So 2x minus y is equal to 1. I'm going to go ahead and subtract 2x from both sides of my equation. So negative y is 1 minus 2x. And so we're going to divide everything by negative 1. So my y is negative 1 plus 2x, right? And now we're going to plug it into the other equation, not the one you started with, but the other one, which is this one, by the way. I don't know why I do that, but anyway, we're plugging it in there. So now it's going to be 2x minus, I'm not writing y, which is equal to negative 3. Now instead of y, I'm going to put negative 1 plus 2x. So it's 2x, negative times negative is positive, so that's positive 1. Negative times negative is negative, so that's negative 2x, which is equal to negative 3. 2x minus 2x is 0, so I left with 1 equals negative 3. Is this true? Last time I checked, 1 is definitely not equal to negative 3. So this is false. And so since it's false, it has no solution. Okay, and that's it for the video. So make sure to like our channel because it does help us reach more students, especially those that would benefit from this video. Also, I'm curious to see what y'all think the next topic we're gonna post in the algebra series is. So whatever you think our next topic is, you want to go ahead and put it in the comment section. And yeah, I'll see y'all in the next one. Bye.